you to help me write the note. What would you say? The graphs of f and f inverse for any function, not just for the one we graphed, are what? Exactly. Yes, perfect. Or symmetric with respect to the line y equals x. All of them. All. So if a function, this is how we normally write in math. A function is defined on set A, taking values in set B. In other words, this is the domain and this is the range. A function is defined on set A, taking values on set B. Its inverse function will be defined on, of course, taking values. Yes, it has to bring them back, otherwise it's not the inverse function. Very good. Okay, so let's look on page 205. We know how to find the inverse. Final question here before we choose a problem. What if I decide to create the function composition? Don't say anything just yet. What if in the function I plug in inverse? Or what if in the inverse I plug in the function? Since they are inverses of each other, they have to cancel their effect on x. I give you $10 and I take it back. These are two operations that are inverses of each other. How much richer or poorer are you? Nothing happened to x. So if you have $10 in your pocket and I want to give you 2 and then I take it back, what are you left with? 10. In other words, x didn't change, right? So when I create the function composition in each direction, what should the answer be on any x? On x, you have x in your pocket. I give you 10. I take 10 back. X. This is called the property of inverse functions. If two functions are inverses of each other, this must be true. If they're not inverses of each other, this will not happen. So on page 205, we are given two functions. Use the inverse function property, which is this, property of inverse functions, to show that f and g are inverses of each other. Please choose if you have your book. If not, I will choose from 25 through 36. Choose any function you want. Any pair of functions, actually. And which one? 31. Okay. 31. I have x squared minus 4 for x greater than or equal to 0. And we are given g of x, the square root of x plus 4, for x greater than or equal to negative 4. Here's my first question. So this is 31 on 205. Okay. We just said something about a quadratic function. What did we just say a minute ago or 10 minutes ago? Exactly. So how can it have an inverse? Right? This is the quadratic function. It's not one-to-one. But look at this, look at what I'm going to do now. Is this portion one-to-one? Yes. That's exactly why they truncate it, we say. Truncate, minimize it. That's why we truncated the domain.
Oh, so we're only looking at that part.
Exactly. Only to the right-hand side of 0. So I know how to graph x squared minus 4. X squared minus 4. But then I remove this, and I only have this portion of the graph. Is this one-to-one?
Yes.
Yes. Good. This condition here is given for the inside, right? We know now that the quantity under the square root has to be greater than or equal to 0. That's why this is there, because this function doesn't exist everywhere. X plus 4 must be greater than or equal to 0. So we understand these two. This is clear for the domain, and this is clear because we had no choice. Not because this function is not defined everywhere, but because we had no choice. Okay, so now I'm given these two functions. I have to determine f comma g, and I have to determine g comma f. What should the answer be if they are indeed inverses of each other? No, exactly x. In other words, x stays there, nothing happened to it. 2x, if I get 2x, the functions are not inverses of each other. If I get x squared, the functions are not inverses of each other. If I get x plus 2, the functions are not inverses of each other. I have to get just plain x, which means one annuls the effect of the other on x, and nothing happened to x. So f comma g is by definition f of g of x, which is f of the square root of x plus 4. And now I'm looking at f. F says blah squared minus 4.
So, f, square root of x plus 4 squared
Yes,
minus 4?
exactly. Very good. But how much is the square root of x plus 4 squared? We solved radical equations a while back.
They cancel.
It's x plus 4 minus 4. So the answer is indeed x. It looks promising, but I still have to show the other one. And you can say why. Well, in this, there are several different types of algebra. In the algebra we are dealing with, if f comma g is x, g comma f will be x as well. But in other algebras, it's not. So that's why we have to show both sides. I mean, we have to show both sides. So now g comma f, so this is g of f of x, which is g of x squared minus 4.
So, square root of x squared
Exactly, the square root
of x squared minus 4 plus 4.
inside, correct. These two go away.
And then square root.
So this is the square root of x squared, and I should write the absolute value of x. But we know that yes, it has to be positive. Yes, that's the reason why it's true. What do I conclude about f and g then? F and g are
Inverses.
inverses of each other. Indeed. I only have 4 minutes left, and I would like to determine the inverse of a function. So please choose one. I'll stop, I promise.
Actually, 48.
37 through 60. Which one?
48.
48. 48. I see it. Very good. So we have 48, which is f of x plus 4x minus 2 divided by 3x plus 1. And find the inverse function of f. So now we should show that the function is one-to-one first. Okay, but I will not have time to finish it. So remind me, I will show you how to show that it's one-to-one on Monday. So we replace f of x by y for x minus 2 over 3x plus 1. In step 2, we interchange. X equals 4y minus 2, 3y plus 1. And now, how do I solve this equation? Yes, how?
You multiply each side by 3.
Right, I want to cross multiply. It's a proportion. That's the easiest thing to do, but it's the same thing what you just said. So 3xy plus x equals 4y minus 2. Because I'm solving for y, terms with y have to be on one side. Which, yes, which means this has to be here and this has to be here. So 3xy minus 4y equals negative x minus 2. And what should I do on the left-hand side? Because I need y, and I cannot combine them.
So divide by 3x.
The terms with y are on one side. I have to combine them, but I can't. Remember 2 key words in this class. What did we say? Correct. Which one? Yes. Of course I have to factor. What am I factoring? Of course, because I'm solving for y. Of course. And y equals? Negative in front as if you're factoring out. That's the elegant way. And as you know, the negative goes with the top. So therefore, final simplified form, I should state that x is not 4/3. That should be included as the domain.